When you're talking about population studies, population study helps us to know. Please, let's keep quiet.
That's good.
Population study helps us to know the number of individuals we have in a particular area and what can be the effects those people impact on the area and what the area also impacts on them. Looking at the population in this place now, it's no longer conducive. So, population study is just talking about individuals, species. We don't expect to be studying rats for now, but in biology, it is important. Rats, population, grasses, population of grasses, population of humans, so that you can talk about balancing of the ecosystem. Population of trees, how a lot of things are spread in the environment. So we talk about population studies. Now, a lot of times you hear different terms under population. This is not a difficult aspect. When we are through now, we'll be through with everything that has to do with ecology before we move on to the next things. So, first thing is, what is population itself? We have defined population, Abi. So population is defined as the total number of individuals of the same species that are capable of interbreeding, Abi. Number of individuals of the same species in a particular area at a particular time, Abi. That we have talked about that before. That's the definition of a population. The total number of individuals or organisms of the same species in a particular area at a particular time. That was where we started our class from. Then after that we talked about community, Abi. You still remember? So now, when you are talking about population studies, there are some terms we hear when dealing with population study. First term is population size. There is difference between population size and population density. Population size. So population size is talking about the total number of organisms of the same species in a particular area. The total number of organisms you have in a particular area. In a particular area, that is the size of that population. The total number of organisms of the same species or organisms of the same kind in a particular area. So just talking about our total number, like the volume. So, how many of us are in this class? We want to talk about the total population of Nigeria now. Do you know that in a small area, you can have more population even than a bigger area? If I have this, and I have this is like Ibadan. This is like Lagos. If you count the populations of people in Lagos, it might be so many. But all of them are choked up in a particular space. Lagos is not that big compared to Ibadan. Abi, Ibadan is very big. So the total number of people we have here is what we call the size of the number of people, the population size, the total number that we have. Do you get that? And which means that the total number we have here might actually be less than the numbers we have here. So it is not the area that determines it now, but the area just has something to say about it. In Ibadan now, we can have a particular population of people. In Nigeria, what's the population of Nigeria? I think the last time they did census was maybe, when was the last time for census? I'm not sure, has your generation ever witnessed census before? Yes. population census, you must have done it in geography. So they will start counting everybody. I remember when I was young then they did population census and they came to our house, they counted everybody in our house and they would mark it that they have counted the people here and they will go to the next house and they will do the total estimates of everybody and they will say that at least some years ago, what's the total population of Nigeria now? We used to know that we are over 200 million in Nigeria. As I the one that me I know, we are 150. No. How can we be 150? There is what we call population dynamics. The total number of individuals can be changing with time. We call it population dynamics. But we should not have such decrease in population when it's not like there's disaster or something. But bí àwọn kan ṣe ń kú àwọn kan ṣe ń bí ṣe you get. And funniest thing is that the total number of deaths is now as if it's even more than the total number of deaths. But those are samplings that they can do or experiment that they can do. So that's why we have a lot. And even if we start looking at population, it's getting to look like we're having more female than male. Things are changing. Although that cannot be true for my own family, because I used to look at it that where are the females coming from? How many of you are only girls in your family? Only girls. How many of you are only boys in your family? Only boys. When you need to go to how can they get say that we are only boys? I don't expect the girl to be that. So, I don't know how that has been for me. My grandma gave birth to 7 children. And out of the 7 children, my grandma gave birth to first 2. Her firstborn and my mom were the girls. So her firstborn and my mom, the remaining 5 boys. And every of my uncles have been giving birth. Maybe just one girl. Calculate population size. That is given as population density. Population size. That is given as population density. Multiplied by the area. So the area occupied by those population. So we saw some, that's why I didn't allow us to use my phone. So we saw some questions. Which one can survive disaster more? Is it a large population or a small population? Yes? Yes? Some of you are saying large, some of you are saying small. Let's say there is a sudden fire outbreak. God forbid. Which one will survive which population is going to survive disaster more? This is large population, not small. A sudden disaster can clear small population and there will never be their generation again. Large troop can destroy all of them. Compared, at least some people will escape. Some people will escape out of the large. God forbid if anything, the total number of individuals per unit area of a given habitat. So if you want to write population density now, that's going to be just make this subject of the formula. So they can ask you to do some calculations here. Is that taking? Or you can just say population density is equal to number of organisms in a given area. So the number of the total number of individuals or the total number of organisms of the same species per unit area, per over the area is the ratio per unit area. keep quiet. Did I ask you a question? Is that taking? So they can give you a question to solve on that. I will give you the question here. Write this question. The population density of Trinidad in an abandoned square farmland. The population density of Trinidad, C-R-I-D-A-X. The population density of Trinidad in an abandoned square farmland. Just connect. Yeah? Yeah? In an abandoned farmland of size 200 meter. Was found to be 5 plants per meter square. Was found in an abandoned square. Note that statement. In an abandoned square farmland of size 200 meter. Was found to be 5 plants per meter square. Was found to be 5 plants per meter square. Full stop. The population size of the plants on the farm is so how do we do that? We are given the population density, Abby, and you are given length of a square. How do you get the area? For square, that's L square, Abby, length square. So you will raise that length, square it, then multiply it by the population density. Do you understand what I'm saying? What are you looking for? Please pay attention, don't stress us this morning. What we are doing is not that difficult, so don't stress it. You are looking for population size, Abby. And what's the formula for population size? Population density times the given area, Abby. And when you are given the population density, that's 5 plants per meter square, something per meter square. That's the number is the number of plants per meter square area. So you are given the density. Then, oh yeah, what's the answer you got? So the total number of plants is what? Oh yeah, now. Do I need to solve that for you? So please, even sometimes population size can still be referred to just like normal population definition. So next one, population frequency. Population frequency. All those terms don't manufacture, so if you are not careful, you might know. Population frequency. Have you all gotten the answer for that one? If you did not get the answer, you better talk so that we'll solve it for you. Over the exam, ordinary let's say this is the square. Then you have several grasses on that land. When you are trying to get the area of the square, that is going to be the length. And since the length and whatever breadth it is the same, so the perimeter will be like L plus L plus L plus L. So that's going to be L square. That's the area for the square. And now you are given the length, Abby, which is 200. So that's going to be 200 square. And be careful of that unit. If they give you the unit in centimeter or anything, you have to convert it. But this unit is given in meter, so it's direct. Most times in biology, they might not want to stress it. The way it's biology is not physics. So this is going to be, is that correct? Eh? That's 40,000 meters squared. Or 4 times 10 raised to power 4 meters squared. Then we already have our density. So the population density is equal to 5 plants per meter squared. So population size is now going to be the density times the area, and that's going to be 5 times 4 times 10 raised to power 4. And that's 5 times 4 is 20. So that's 2 times 10 raised to power 5. Plants. Don't say plants per meter. Check it. You know, here now it is plants per meter square. Plants per meter square is talking about the total number of plants in a given per unit area. That is density. But the total number of plants is talking about how much, the size, how many plants we have. So we have this number of plants. All these are basic things. So next, population frequency. This is defined as the number of times. This is defined as the number of times an individual occurs in a population. This is defined as the number of times an individual occurs in a population of a given area. The number of times an individual occurs in a population of a given area. Now, right, let me give you this definition before I explain this. Sorry. Population cover. Population cover. This is defined. You see that almost everything is standing up like the same. This is defined as the area or volume of space. This is defined as the area or space occupied or volume of space occupied by a set of individuals or population by a set of individuals or population in a particular habitat. In a particular habitat. Now, from this example I did the other time, Lagos and Ibadan. In this given area now, there are some set of people there. If you look at the space in Ibadan, there are even a lot of spaces where they are already cutting down trees and building houses. So in Ibadan, the population covers a lot of land, a lot of areas. I hope you are listening. But in Lagos, because Lagos is not that big, so I was looking at something that moving in Ibadan, you still be seeing bush left and right. If you want to go from this Elena to Ido, you will meet bush all along the way. But if you want to go from Oshodi to Ajegule in Lagos, you might not see one tree like this. You might not see one bush. Everywhere has been covered. Everywhere has been totally occupied by people. That's why you can see in some areas in Lagos. How many of you came from Lagos? Maybe from the side of Ipaja, from Solo, from if you come from those areas, you would have witnessed some families that in a single room You will see a lot of people living in that room, in a single room. When I was young, there are some people I used to go and visit in Lagos that every time these people are coming back from work. Normally, when I was young, my dad used to come back late from work, 12, 1 o'clock, midnight. Yeah, those days. But these ones, young guys that are working, they live in that same, it's just like a room and parlor. The father, the person that has everybody and his wife and his own children, they are living in that same room and parlor. Grown up, the many of the uncle, auntie, everybody is also living in that same room and parlor. So, then the place we call sitting room. Everybody, so people will be sleeping on the floor like this, and they're happy. Then I have some abundance. When they come back around that 12, 2 o'clock, they will come back. You that you are young, you would have slept. So they will just sit on the chair like this. So I just see them. And before they come back, they will say, Nika, let me buy yam and beans. Can you come? I said, I slept one. Oh, I never come to buy. Open your eye by 4 o'clock, you will not see them again. What is too long? You wake up 4 like this, you just look at them. 2, 3 hours. That's their sleeping hour. They are gone again. So, house was not really a problem for people in Lagos. Even in the compound, outside the gates, everybody will go and sleep there. Mama tell you, Lord, sit alive. Everybody will sleep. One thing about them, that was a Ajegule there. One thing about them is everybody just wants to see where to put them to survive. So, a wife can still marry and even her husband will join them. They play. So sometimes, if we see some people don't share our cup, one of those things, that will not be your own portion. Amen. So this will be better for them. You have never even experienced anything. You now is flat, a room to yourself. Your mommy will say, hello honey, how are you doing? Honey, I'm still sleeping. So the area those organisms cover, the area they occupy is what we actually, so even as this place is big, they might just cover a little space. Or they just go in and all of those things. Just those particular space that organisms cover is what we call population cover. Do you get that? It's just from the terms. Kini size, what she photo, what she told you, kini density, what she photo. If you have a bigger size in a small area, that we have a higher density, Abi. Because this place is not so big, so our density for this same size is getting to be too much. Do you get that? When we are all packed together is what we call density. So we can have the same size in a bigger area, and you can have the same size in a smaller area. Do you understand that? That's density. Then how many times do I used to see you often times? This number of persons, I see you often times, so I can say, oh, this is the number of times I'm seeing you. Hello? What will help you to pick your answers now are the ones I'm saying, it's not your notes. So how many times am I seeing you over and over? Then that is called what? Frequency. Do you get that? Then what particular area do you cover is what we call population cover. So I will ask you 1 or 2 questions. Then you will answer me. Then population distribution. Population distribution. Population distribution. This is defined as the manner. This is defined as the manner in which individuals or organisms of a particular population. This is defined as the manner in which individuals or organisms of a particular population organisms of a particular population are arranged in a given habitat. The manners in which individuals of a particular population are arranged in a particular area. It's just like share. Look at all of us now. I can say some set of you go here, some set of you go there, then some set of you. So population can be said to be, population distribution can be said to be choked or clumped. So you can clump some people together because of how you have distributed them. Then some can be said to be randomly spaced. Some can be said to be evenly distributed. So I can take some of the populations now and arrange you in a way. You know, sometimes now I can say, how many people are here? 5. I can look at them that you are supposed to be 6. I add one more person. Then I add one more person. Then they can no longer sit. They are now sitting like this. Then I choke all of them together. Then that is just clumping them together in my distribution. So clumping all the organisms together. And that can have serious negative effects. I mean, let's say I take a 1,000 of fishes in a very small water. I just pour them in one. Then another same size of food. I just put like 5 fishes. And I give them regular foods and all. The ones that they are numerous, we start having problems with time. Because their waste products will be affecting that population because they are clumped together. Do you understand what I'm saying? Yeah. So just picking all those organisms and putting them in different spaces is what we call population distribution. So, next one. I think that's all. Let me ask you these questions. Listen to this question. Question 1. And you are going to tell me what you feel the answer can most likely be. And I can call any one of them. Number 1. Listen. The number of individuals, just listen, don't write. The number of individuals in a habitat in relation to the unit space available to each organism is referred to as what? The number of individuals in a habitat in relation to the unit of space available to each organism is referred to as what? A, birth rate. B, density. C, mortality. Some options will even give you answer itself. D, frequency. E, dispersion. Yes. Best answer is what? Density. Is that taken for that area? Number to 1 there. That part. Since there is no population size, it wants to sound more like population size. But if you listen to it very well, they are just talking about the number of organisms per. That's why they said in different spaces. That means per this space. Do you get that? So it's not everything that they have to make straight. Even if population size is there, best answer would have been population density. Because they are saying that the total number of individuals. Listen to that question again. That's why biology can be corny somehow if you are not careful. The number of individuals in a habitat in relation to the unit space, to each organism is referred to as density. So the number of individuals per space. This is your space. This is your space. This is your space. Is that okay? I think we have said this before. The population of different organisms living and interacting in a given habitat is called what? We have said this before. Population of different organisms living and interacting with one another is called what? Community. Is that taken? Option. I didn't give you option for that because I know you should know. A. Bio. B. Community. C. Ecosystem. D. Niche. I told you the difference between ecosystem and community for you to know when to pick. Population of different organisms in relation to their non-living environment, that is ecosystem. But population of different organisms interacting with one another, that is community. Do you get the difference? Which of the following is not true about population? Which of the following is not true of population? A. Members of a population may be of the same species. True or false? True. Members of a population are usually organisms of the same species. Abi? Option B. Members of a population may be of the same species. Even in the hostel, sometimes some people come and say, oh, they want to join the hostel. I'll tell them there is no space. The hostel, I'll tell them there is no space again. So our population can be limited by the available space. Not be serious. It's normal. Nobody wants to not be serious. It's normal. Nobody wants to. I was just thinking about everything that, is it by force? Do I have to teach? There are some things that I should have read now. Even when I was talking to Ben this morning. When he was like, so you are resuming next week. I said, yes. He said, you have not read. I said, I shall take conviction and we pass. But I understand everybody that been calling me and they say, hey, you are supposed to read some of this before you resume. Or else. But I said, I will do that in 4 days. And I will know how to do everything. For like 2 months now, some people have been reading everything we are going to do. And it's because the work is much, so they have no choice. They have to read it. Except the perfect barren. So they made us to know that medicine is not a place where you will read and crash read. All those matters left now. I even said I'm not going to write or read. I'll just go for exam. 100 levels. That was me for 100 levels. I never read. And I'll continue them until they don't learn number. My computer now is in computer science. I had B computer because I don't know it. I read it to some extent. Mathematics now, I had A in 1 and I had A group in 1. I had E in 1 and I had A in 1. I did not really know mathematics. But physics, chemistry, they wake me up 100 times. I never had B. So those ones are normal. But English now, I had 69 in English. I just need 1 to have just 1. But when I wish I had joined Mr. Phillips when he used to teach, it's all those things Mr. Phillips used to teach that they taught in English. All those what did they use for the double thing that they Concord. All those tenses, adverbial clause, adverbial NECO. In my test, going up from my own, I had 37/40 in test. 32/60 in exam. That's how crazy. So 69. But that's by the way. But that elective of diseases and no, those ones I don't need to read. What causes HIV? What causes global hemolysis? I had it down. Then the one for history of Nigeria, amalgamation, this and that one which will be every day. I was now happy that my batch was the last batch. So as the first batch came out, what did they ask you? They say, I'll just write everything they asked them. Second batch, what did they ask you? Write everything down. Third batch, I say, it's the same thing they asked first batch, second batch that they asked you. Is that so? Oh yeah, give me the ones you can remember. I just cracked like 60 to 70 questions. I didn't even bother. And I saw that, nice one. If not for that, only God knows. Only man in fact type of man here go. So I have to read too. But deliberately I know the little I do with you will go a long way. So let me just do the parts I'm supposed to do first before you go ahead and do the rest. So work on yourself. The next one. I think the last option. Listen to this, because options can be confusing at times though, but you must be deliberate. From these options now, option B looks very correct, because population should be able to interpret. But this one says that some species can form another population elsewhere. True or false? True. A species can, even a species can lead to another species. We call it speciation under evolution. You remember how Darwin's species started to now give rise to different species of birds. So all those things can happen. So that is true. Then option. So make sure you solve questions. Members of a population must coexist. Members of populations must coexist. Members of population must coexist, true or false? Can you depend on yourself? No. Coexistence is part of life. An individual cannot live on his own. Only me, depression happen. So everybody must, you need that one another. That's why you can't neglect. Even the Bible already said it, that do not forsake the gathering of what? So if they ask me in biology, you write it. If they say that members of the same species must coexist, you say yes, this is even confirmed in the book of this and that do not forsake the gathering of the brethren, and you submit it for WAEC. I want to pray. So let's look at. I'm giving you the calculation. Right. Next one, next definition, population dynamics. Population dynamics. I hope you are okay with those first parts. I'm only asking you questions because I know they can sound confusing at times. They might be very simple, but sometimes they sound confusing. Population dynamics. This is defined as the study. This is defined as the study of how population change or how population changes with time. This is defined as the study of how population changes with time. With time. Paragraph. If a population size doubles at constant rates for a given time. If a population size doubles at constant rates for a given time, this is referred to as exponential growth. We are still going to talk about growth curve later under maybe reproduction. This is referred to as exponential growth. Exponential growth. We usually see that in exponential. This exponential growth, we usually don't have it among humans. You don't expect that the population of humans should be cocoa on the day times 2, times 2, times 2. It does not really happen. Or else. But exponential growth is seen in microorganisms, in bacteria especially, so you can take notes. This is usually seen in population of bacteria. You know, bacteria, they grow by binary fission, Abby. So the one individual just divide to 2. That means the 2 will divide to 4, Abby. 4 will divide to 8. 8 will divide to 16. You can see the way that population will just grow suddenly. Then we call that exponential growth. Is that taken? Let's look at factors that affect population growth. Maybe you should explain. Factors affecting population growth. Number 1, natality. Natality. What's natality? This is known as the birth rate. That's birth rates. Rate at which organisms are giving birth to. We call it natality. Right. It is the ratio of the number of births. It is the ratio of the number of births to the size of a population. What now? Size of a population. So increase in size of a population. Now, if you are to increase the size of a population or decrease the size of a population, what should happen to the natality? Increasing natality will increase population size. Abi, while decreasing natality decreases population size. And please, decreasing natality does not mean that there is more death rates. Get that statement right. When you decrease natality, it means you are regulating. You know, there are some places that normally, even in the same country or in some organizations. When I was in Lagos now, I have a place where my uncle was working, and the company, like all this Shell, Chevron, if you are working there, they help you to take care of your children. But those children, they are the ones that pay their school fees, everything about the children and all. But it is only 4 children. If you give birth more than 4, problems here. So those 4 children, they even used to send a carton of them, his recharge card. So they will send a carton of recharge card to them. So they don't, these children, if they are going to school, they don't take car. They school in Port Harcourt, but they are living in Lagos, secondary school. So if they are traveling, they will tell you that cars, their bomb will be paying them, that will be paying them. So they always travel with flights every time. I don't mind. So work hard. May your children don't remind you history. Work hard. So it does not mean that you are taking part and you are poor. And you that you are trekking, you are not poor. Yeah, I've trekked enough in my life. Like I've trekked. Even my friends at the stage, when we are going out, they will say, anything YK, anything Fatu says, don't just answer. As we are going out, by the time we get to, let me just use some go to LA to describe. Then, they just like, don't you be like, Fatu, where will they go? Will they go Sabo? From Mayfair in Ife, then you know it. Mayfair to Sabo is very far. It's like trekking from Songo to, let me say, to there or that one is very far. It's farther than that. So as we are going, Don't do not say, when we go reach there, I'll say, I will go so reach. Don't worry, at that front, we go so reach. Shall keep going, keep going, keep going. Like, next time, don't ever carry NECO out. What's the money, Lara? And in tomorrow, in the secondary school, every day. So, let's go on. Next, mortality. So in population, they can regulate births. Many of you now, if the government says that don't give birth more than 2 or more than 3, they can regulate it. In some countries, they can regulate it. In countries, they just give birth anyhow. I think the highest population is India or China. I think I know it one. I think it's China. So mortality talks about death rates. So mortality is defined as the number of deaths recorded. That's why if people die in hospital, most times they want to actually record it before they give birth certificates. They want to. But some people, if someone die like this, they will vex and say they want to carry their body immediately. And all of those things. So, number of deaths recorded in a given population at a particular time is what we call death rates. Number of deaths recorded in a given population at a particular time. So next is, all these ones you know them, immigration. I-M-M-I-G-R-A-C-I-O. Immigration, emigration, emigration, immigration, food availability, all these are things you should use your natural disasters. We are listing them, then we will explain them because of time. Natural disasters. You know natural disasters. Fire outbreak, earthquake, flood. Are you listening there? Flood, fire outbreak, earthquake, tsunami, volcanic eruption. You saw that what happened in, I think it was during COVID. It's in Libya. There was one explosion. Like they stored chemicals during COVID. You know, people were not able to go to work. So they stored some ammonium nitrates in the factory. And due to heat, I don't know if it's Libya or, let me see if I can check it. It's affected the whole lot of you can see the person recording God. Go there. It first started like smoke like that then. It will spread now. Look at where it will spread. It touched the whole lot of buildings. I forgot the place. So that's by the way, and that kills a lot of people. That can use the population size. I'm still going to talk about density dependence and density independence. So, who can explain what's the difference between immigration and emigration? So, enemies existing, going out. So when there is a sudden movement of a population size out of a country, then or out of a particular space, then we call it emigration. You remember what happened after COVID? That they were needing nurses, doctors abroad, and all of our nurses in Nigeria escaped groups. All our doctors escaped groups. So I want to go to Nigeria by manage your doctor. So that is the thing. So that happened, and if a lot of people that don't even know what they want to go and do there, everybody jump back. So we always start regulating it. So but coming in, so suddenly flow of large size of individual into a population. To US now, to Canada, to UK, to them it will be immigration. To us it will be emigration. So we are going to have a decrease in population size. They are going to have an increase in population. So those are common things. Which one did I say again? Food availability. In a country where there is food, when my friends first got to Europe, he went to buy tomato, bought a lot of things, and he recorded it. He said that this is like 5,000 naira in Nigeria, and he sent it to me. Only white cake, tomato and pipe. And he recorded and he sent everything and all of those things. So, abroad, food is available, food is cheap. But here, food is expensive. And that can lead to a lot of things. But we are just strong, we are facing it. So that's about that. Then, population study. Let me quickly give you this. Right, methods of population studies. Methods of population studies. Methods of population studies. Number one. Wait, right. Let me skip a part. This is known as sampling method. This is known as sampling method. We study population in biology. We call it sampling. They can ask you. This is called sampling method. We have two types, but that one we don't really need to talk about. You can talk about it in geography. We do census, Abby. So census means we will start counting. But in biology, we do majorly sampling. So I can take a quadrant now. So that one is called quadrant method. They will just be flipping something. They use that to know the number of grasses in the field. So let's list them. Types. Types of sampling method. Number one. Types of sampling method. Quadrants method. Quadrants method. This is used to determine the average number of individuals. This is used to determine the average number of individuals of a given species. Average number of individuals of a given species in a particular area. So they segment the area. In a particular area. A quadrant is a square shaped or rectangular shaped metal A quadrant is a square or rectangular shaped metal that is thrown randomly. That is thrown, a square or rectangular shaped metal that is thrown randomly to a particular area. That is thrown randomly in a particular area. Randomly in a particular area to determine the number of individuals averagely in that area. To determine the number of individuals averagely in that area. Averagely in that area. So they just throw it, but you do different samples. So the formula, you now calculate average. You throw for the first time, you count the number. Please listen. This is how you do your calculations on quadrant method. When they take that metal, they throw it the first time, then the total number of organisms around that area will be counted. That's one. After you have counted it, that's your first throw, Nabi. You throw it again, that's the second time, you also count it. You will add the number in the first one plus the number in the second one. How many times have you thrown it? Twice. You throw again. So if you throw it 5 times, you will add all of the numbers you have thrown that you have counted together. Then you divide it by the total number of thrown. Is that taken? That's how you do the calculation. Throw it 5 times, count the total number of organisms for the 5 times, add them all together, divide it by the total number of thrown. That is how you determine the average number for that given area. So the formula is average number of organisms. Average number of organisms equals total counts we start here. Total counts of individuals over number of throws of the quadrant. Total counts of individual over the number of throws. Number of throws of the quadrants. Let me just give you an example then we stop the class. Then I'll complete what I started in chemistry before your break. In a quadrant sampling question. In a quadrant sampling experiment, using a quadrant of 1 meter square. In a quadrant sampling experiments. In a quadrant sampling experiments, using a quadrant of 1 meter square. Using a quadrant of 1 meter square, comma, the following were recorded. So we have a table. Let's be fast. Sampling, number of carpet grass per quadrant area. So you have, for the first sample, you counted 10. For the second sampling, you counted 12. For the third, you counted 14. For the fourth, you counted 6. For the fifth, you counted 4. For the sixth, you counted 18. For the seventh, you counted 20. For the eighth, you counted 11. For the ninth, you counted 13. Then for the 10, we counted 9. So, now right. Are you through with the diagram? Are you ready? You remember that you were given the area of the quadrant. The quadrant itself. That's 1 meter squared. So for that area, there's an average number existing to carry. So right, if the area of field studied, the total area of field studied is 200 meters squared. If the area of field studied is 200 meters squared, calculate the population density of the carpet grass. Calculate the population density of the carpet grass. So, how do we get the density? What's density? Density is number of the organisms over the area. I think we're given the total area. The total area is 200 meters squared, and they asked us to look for. So the next question is, how do we get the total number of organisms in that area, in that 200 meter square area? Not just the sampled area, in the total area, the density, after the sampling. So number of grass per quadrant area, per quadrant, is what we are given. So per quadrant now, this is the total number we have counted. So can we get the average number? So the average number will be the total count of individual over the what? The number of times we have thrown the quadrant. So do that. What's the total number? 117. So the total number here is what? 117. How many times did you throw it? 10. So you do 117 over 10. That will give us the average number. Average for 1 meter square. For a particular. You know the quadrant is 1 meter square, not for everything. So for 1 meter square, when we throw, there's a particular area, 1 meter square. When we throw again, there's a particular area. How many times did we throw it? 10 times. So that means that we have only covered 1 meter square 10 times. 10 times. That means we are only covered 10 meters square, not everything. Let's get the first answer. Oh yeah. What's the answer for this? 11.7. You got 11.7. It's just like, yeah. Even if we times, can we multiply? Can we do 117 times? If number of individuals is 117 and the area is 200, because you cannot tell the number. So averagely now,
I just put another new thing.
area of quadrants. What do we have? Class. Do we have 200 meters? That means X is going to be 2,040 carpet grams. It's just a rough estimate. So that means the total number of carpet grams we have in the whole 200 is 2,040. Then to get density now, we can say density is total number of carpet grass over the total area. And that's going to be 2,340 divided by. And that gives us what? Can you see? 11.7 So we'll talk about the rest tomorrow. Complete the rest. Succession. Since we finish that, so that's all. So where's the mic for chemistry? We are your mic. Let me to pass the mic.
Yeah. Who's the